Hello everyone. Today I am going to start sequences and series. In the sequences, first I am going to explain about sequence. What is a sequence with example, and then convergent sequence, divergent sequence and oscillatory sequence, and then we will go to the infinite series. What is series? Now sequence. For each natural number, I think everybody know about natural numbers denoted with capital N, 1, 2, 3, 4 and so on up to N, up to plus infinity are called natural numbers. For each natural number N, a number An is assigned, then the number A1, A2 and so on An is said to form a sequence. Now, if for each natural number n, with example I will explain. Now, this sequence is denoted with an, and an is called nth term of the sequence. Sequence is always denoted with within flower brackets an. An is the nth term of the sequence. Example, if I give you one example, you can easily understand. If an is equal to n square, if an is equal to n square is a sequence. For example, the sequence an is equal to, if you put n is equal to 1, I am expanding this sequence. This is the nth term. An is equal to n square is the nth term of the sequence. I am expanding the sequence. I am substituting n is equal to 1, 2, 3, 4 and so on up to. Now if you put 1 square is 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25 and so on. Now 1, 4, 9, 16, 25 and so on you will get. Now the sequence, how to define the sequence means, now this is the set of natural numbers 1, 2, 3, 4, 5, 6 and so on up to n and so on up to infinity. Set of natural numbers. That this is another set. Now in this one, now for every natural number, a set of natural numbers, there exists a term in the form of an. Now for 1, for 2, 4, for 3, 9, for n square. Now for every natural number, for each natural number n, a number an is assigned. There exists an, there exists an an. Then such type of, then a1, a2 and so on an is called, here a1, a2, a3 and so on an is called a sequence. Now this is called sequence, not this one. Now I'll with one example I'll write. This is one more example to this one, 1, 2, 3 and so on up to n, to the natural, this is natural number set, this is another set 1 by n. If you elaborate this nth term, an is equal to an, if you elaborate this one, an is equal to 1 by n, 1 by 1 is 1, comma 1 by 2, 1 by 3, 1 by 4 and so on. If you expand this sequence 1 by 2, 1 by 3, 1 by 4 and so on, you will get. Now 1 by 1 is 1, 1 by 2 is 1 by 2, 1 by 3, 1 by 4 and so on. For n, 1 by n, like that. Now for each 1, 2, 3 and so on n, this is set of natural numbers, this is another set, a1, a2, a3 and so on an and so on up to infinity. For each natural number n, there exists a definite number an, there exists or there assigned a definite number an, then a1, a2, a3 and so on an, a1, a2, a3 and so on an is called a sequence. It is denoted by an, it is denoted by an. To the integers 1, 2, 3 and so on, there exist definite numbers. These are also numbers. There exist definite numbers a1, a2, a3 and so on an. Then a1, a2, a3 and so on an is called a sequence. It is denoted by within flower brackets an. Now there are three types of examples you can take. An is equal to this. An is called nth term of the sequence. An is called nth term of the sequence. Sometimes they'll give you elaborated sequence, sometimes they'll give you just nth term. An is equal to n square, or an is equal to 1 by n. An is equal to some number, nth term they'll give you. Now there are three types of sequences are there. The first one is convergent sequence. The second one is divergent sequence. The third one is oscillatory sequence. Now what is meant by convergent sequence? A sequence an is said to be convergent. When will you say the sequence an is convergent? If limit n tends to infinity, an is finite. Now a sequence an is said to be convergent if limit n tends to infinity, an is finite. For example, the value, if you simplify the value limit n tends to infinity an, if you find the after simplifications, if you get a finite number, any number, a finite number, either 1, 2, 3, 4 or 1 by 2 or 1 by 5, whatever the number, a finite number if you get, then only we say that it is a finite sequence. Example, I'll take you one example. 2, 3 by 2, 4 by 3, 5 by 4 and so on is a sequence. Now if you, this is the elaborated sequence. One sequence is in the form of like this. If you find the nth term of the sequence, you will get the nth term as 1 plus 1 by n. Nth term as 1 plus 1 by n. 1 plus 1 by n. If you put n is equal to 1, you will get first term. If you put n is equal to 2, second term. If you put n is equal to 3, third term. Like that you will get n is equal to 1, nth term. If you this is the elaborated nth term. This is the nth term of the sequence. Now if you put n is equal to 1, first term, n is equal to 2, second term, n is equal to 3, third term, you will get. Now an is equal to 1 plus 1 by n. Now limit n tends to infinity, limit n tends to infinity an. Wherever n is there, in place of n, if you put infinity, 1 plus 1 by infinity. 1 by infinity is 0, 1 plus 0 is equal to 1. Now wherever n is there, in place of n, if you put infinity, 1 by infinity, some number by infinity is 0. Therefore 1 plus 0 is equal to 1. 1 is a finite number. 1 is a finite number. Therefore the sequence an is convergent. When will you say the sequence is convergent? Limit n tends to infinity, an is a finite number. Limit n tends to infinity, an is a, if you get as a finite number, then we say that it is a convergent sequence. In the same way we can write so many examples, we will see while doing the problems. Now the next one is divergent sequence. Divergent sequence. A sequence an is said to be divergent if limit n tends to infinity an. Limit n tends to infinity an is equal to either plus infinity or minus infinity. Either plus infinity or minus infinity if you get, then only we say that it is a divergent sequence. Now for example, a sequence an is equal to n square. An is equal to n square is given directly here, nth term is given. If you elaborate also, you will get 1, 4, 9, 16, 25, and so on you will get. Now this is the nth term of the sequence. An is equal to n square I have taken as example. Now limit n tends to infinity an. Wherever n is there, in place of n, if I put substitute n is equal to infinity, you will get n square as infinity square is nothing but a plus infinity. Plus infinity, if you get limit n tends to infinity as either plus infinity or minus infinity if you get, then what is the meaning of that? Then an is divergent. Limit n tends to infinity, an is equal to either plus infinity or minus infinity, then we say that it is a divergent sequence. Now the third one is oscillatory sequence. Oscillatory sequence means it oscillates between any of the two numbers. Oscillates. It oscillates. That means it may be anything between any two numbers. A sequence, when will you say it is oscillatory? A sequence an, it is neither convergent to a finite number nor divergent to plus infinity or minus infinity. Then it is called oscillatory sequence. That means limit n tends to infinity. Limit n tends to infinity an, if you find, you won't get a finite number. You won't get a finite number, or you won't get any plus infinity or minus infinity. That means you neither get neither convergent nor divergent, or neither you will get neither finite number nor plus infinity or minus infinity. Then we say that it is oscillatory sequence. For oscillatory sequence, the example is an is equal to a sequence. An is equal to 1 by n plus minus 1 to the power of n into 2. 1 by n plus minus 1 to the power of n into 2 oscillates between minus 2 and plus 2. How it is oscillates minus 2 and plus 2? See. Now, how it is between minus 1 and plus 1? If n is equal to 1 in this sequence, nth term of the sequence, if you put n is equal to 1, how much you will get? 1 by 1 plus minus 1 to the power of 1 is minus 1 only into 2. 1 minus 2. Minus 2, 1 minus 2 is minus 1. You will get minus 1. Now, if you put n is equal to 2, how much you will get? If you put n is equal to 3, how much you will get? You verify, then example of oscillatory sequence is an is equal to 1 by n plus minus 1 whole to the power of n into 2. Oscillates between minus 2 and plus 2. Then if it oscillates between minus 2 and plus 2, then we say that it is oscillate sequence finitely. Now, to find whether it is oscillates finitely, if you put n is equal to 1, 3, 5, 7 like that. If n is odd, you will get the number between minus 2. If n is even, the number you will get is between plus 2. The value whatever, if you substitute n is equal to 1, 2, 3, 4. 1, 2, 3, 4 means if you substitute n is equal to odd numbers, whatever the value you will get, this is in between minus 2 and plus 2 only. Now, in the same way, few more examples I will give you. For oscillatory sequence, for oscillatory sequence, an is equal to minus 1 to the power of n is a sequence. Now, limit n tends to infinity, an is equal to, now if you put the first one, minus 1 to the power of n is equal to 1, 2, 3, 4, 5, 6 and so on. If you put, how much you will get? Plus 1. If n is odd, minus 1. N is odd, you will get minus 1. If n is even, plus 1. If n is odd, minus 1. N is even, n is equal to 1. You will get minus 1. N is even, plus 1. Minus 1, plus 1, minus 1, plus 1. You will get like this and so on. Now, in this one, if you put n is equal to 1, minus 1, n is equal to 2, plus 1, n is equal to 3, minus 1, n is equal to 4, plus 1, like that you will get it. That means, I am talking about the first example. You will get like this. That's why limit n tends to infinity, an is equal to minus 1, n is odd, plus 1, n is even. That means it oscillates between minus 1 and plus 1. This is first example. In the same way, we will see the second example. An is equal to minus 1 to the power of n into n. This is the second example for oscillatory sequence. An is equal to minus 1 to the power of n into n. Now, if you take limit n tends to infinity, an is equal to, if you put n is equal to even number, n is equal to odd number. If you put n is equal to even number, for example, if you take odd number, n is equal to 1. If you take n is equal to 1, 1 means minus 1 to the power of 1 is minus 1 into 1 is minus 1. N is equal to 2. Minus 1 whole square is plus 1. 2 into 1 is 2. N is equal to 3 like this. N is equal to 4, 5, 6. That means you will get the values in between minus 1, minus 3, minus 5, minus 7 and so on up to minus infinity, and plus values are 2, 4, 6 8 and so on up to plus infinity. That means limit n tends to infinity an, limit n tends to infinity an is equal to, you will get plus infinity or minus infinity. If n is odd, you are getting minus 1. Minus 1. N is odd. If n is even. Now n is odd like this, you will get 1, 2, 3, 4, 5. That means bit minus infinity, between plus infinity and minus infinity it oscillates. Hello everyone. Today I am going to explain about infinite series. Infinite series. Now the definition of infinite series is, now we know about the sequence. Let un is equal to u1, u2, u3 and so on, un up to infinity be a sequence of real numbers. Now u1 is equal to u1, u2, u3 and so on, un up to and so on be a sequence of real numbers. Then the expression u1 plus u2 plus u3 plus u4 plus and so on, un plus and so on is called infinite series and is denoted by n is equal to 1 to infinity un or simply sigma un. Simply sigma un. It is denoted either like this, n is equal to 1 to infinity, or just simply sigma un. Now this is about series, infinite series. Here what is u1, u2 and so on, un up to infinity? It is a sequence of real numbers. Then the expression u1 plus u2 plus u3 plus and so on, un plus and so on is called infinite series and it is denoted by limit n tends to infinity, limit n is equal to 1 to infinity un or simply sigma un. Now here the sum of first n terms of the series, the sum of the, in this series, in this infinite series u1, u2, u3, u4 and so on un, in this infinite series u1, the sum of first n terms s1, the sum of first n terms of the series is given by, the first term is denoted with s1 is equal to either u1 or a1. Here we took u1 or u1. The first two terms u1 plus u2, we took u1 plus u2. So the sum of the first two numbers u1 plus u2, the sum of the first term is u1, the sum of the first two terms u1 plus u2, the sum of the first three terms u1 plus u2 plus u3, that may be u1 or a1, anything you can take, that is your wish. u1 plus u2 plus u3, the sum of the first three numbers I am denoting with s3, the sum of the first two numbers u1 plus u2 I am denoting with s2, the sum of the first term is u1 is equal to s1, in the same way and so on. The sum of the first n terms u1 plus u2 plus u3 plus and so on u1 plus u2 plus u3 plus and so on un is denoted with sn, these are called s1, s2, s3, s4 and so on, sn are called partial sums. In the infinite series s1, what is s1? S1 is the sum of the first term, s2 is the sum of the first two terms in the infinite series, s3 is the sum of the first three terms in the infinite series, sn is the sum of the first n terms in the infinite series. Now here three more important definitions here, just like previous one: convergent series, divergent series and oscillatory series. What is convergent series? What is divergent series? What is oscillatory series? Now consider the infinite series. Now here this is the infinite series. Sigma un is equal to u1 plus u2 plus and so on un plus and so on up to infinity is the infinite series. The sum of the first n terms is denoted with Sn is equal to u1 plus u2 plus and so on un is the Sn. That means the sum of the first n terms. Now the first definition, convergent. Limit n tends to infinity Sn is equal to, if you get a finite number, then only we say that sigma un is convergent. Limit n tends to infinity Sn is equal to a finite number, if you get, then only we say that it is convergent. If limit n tends to infinity Sn is equal to a plus infinity or minus infinity, if you get either plus infinity or minus infinity, if you get, then we say that sigma un is divergent. What is this limit n tends to Sn? Sn is the first n terms of the series, infinite series. First n terms, partial sum. First n terms of the infinite series. Now, if Sn, which is neither convergent to a finite number nor divergent to plus infinity or minus infinity, then it is called oscillatory series. We can take any example for these three problems, just like previous one. Now, here also, what is oscillatory series? Limit n tends to infinity Sn is equal to, if you get neither convergent nor divergent, or neither convergent to a positive a finite number or divergent to plus infinity or minus infinity, then we say that is oscillatory series. And then here from after this we have so many tests we'll get, and I'll tell you all the tests one by one.